Okay, hello everyone, welcome back. So this is another data analysis video. Again, focusing on visualization of data, so exploring data through plots and graphical representations. In the previous video, I demonstrated how to use the seaborn displot method to create plots to assess the distribution of variables. And the displot method combines histograms with kernel density estimators and empirical cumulative distribution functions. And I said I'd make separate videos about each of those things. I've previously made a video about histograms, but I will, in this video, what I will do is kind of demonstrate how to create kernel density estimator plots, KDE plots, or just density plots as they're commonly referred to, using both matplotlib and seaborn. So KDEs are an effective way to plot the distribution of variables. They're kind of one of my favorite ways to do that. If you think about a histogram, what we do to plot the distribution using a histogram is we kind of sum up the values, the frequency count of values, and then we plot each value on the x-axis and the count on the y-axis, and that gives us an indication, using discrete counts of the distribution of the data. So a KDE, a kernel density estimator, is just like a continuous version of that, rather than the counts being discrete. It's like a continuous plot to give us an indication of the distribution of a variable or our variables. Okay, so in order to do this, I'm going to import a number of libraries. I'm going to import pandas as PD, numpy as NP, scipy.stats as stats, and I'm going to import matplotlib.pyplot as PLT, and I'm going to import seaborn as SNS. So kind of the usual type of nicknames when we're importing those software libraries. So mostly what I'm doing here is I'm going to use matplotlib to start with, to get some distributions, to get some densities, some KDE plots, and then I'll demonstrate the same sort of thing using seaborn. One thing to note here is I've imported scipy, and that's a software library that that's useful for a lot of statistical analysis in Python. The reason I imported it is in order to create density plots or to create KDEs using matplotlib, you need to have one of its dependencies is scipy. There's a method in scipy, Gaussian KDE, which it relies on. So if you didn't import scipy, as I have done here, when you try to create these KDE density plots in matplotlib, you get some sort of error message. It tells you you'd need to have imported and have scipy running. So I'm just going to run that first cell and import the different libraries that we might need. Okay, and then what I'm going to do for a data frame for the first bit is I'm going to create a data frame using pandas, the pd.dataframe method, and I'm just going to create a data frame of random data. Okay, so all I've done here is I'm in the parentheses for pd.dataframe, I've passed mp.random.randn. So I'm basically using numpy's random.randn method to create a data frame of random numbers, and I'm asking for 500 rows and 4 columns essentially, and then I've specified the column names in this second parameter here, this second argument. Columns equals Monday, Tu, Wed, Thursday, so Monday, Tuesday, Wednesday, Thursday, and I've set that to a data frame object called df. If I run that, what we've got is a nice pandas data frame. The data in these contained under each of these day of the week variables is just random numbers essentially. It doesn't matter what it relates to. Let's pretend we've measured different things we've measured something across different days, whatever it is. But all I'm going to do is use this to create some plots. So it's made up data, simulated data. Okay, so the first thing I'm going to do is use matplotlib to create a KDE plot, a kernel density estimator plot. And I can do that by using the df object and then just .plot. And in the parentheses for the plot, I can specify the kind of plot that I want. So kind equals KDE. If I just use this plot method and not specify the kind as KDE, it will probably just give me some sort of line graph or something like that, which would look very messy with 500 rows of data. But if I run this command, you can see there we've got these nice continuous density visualizations, one different colors representing different days of the week. So we can see what the distribution of the data is for Monday, the blue line, Tuesday, Wednesday, Thursday, and it's looking quite normal, quite sort of quite peaked, but a bit of a normally distributed curve for all of those. There's a bit of variability, centered around 0, so a mean of probably about 0. So to run that, I specified the kind in the parentheses, and I used KDE as a string, so I inputted a string, so KDE in quotes. Could have done that a different way, and I could have used this command here that you can see. This is going to produce exactly the same plot. I'll leave that cell there so you can see the difference, but df.plot.kde and then some parentheses, and that will produce exactly the same plot. So 2 ways to obtain the same thing, essentially. Okay, so we've plotted every one of those 4 variables there on the same plot, so we can see how similar they are. The density method produces the exact same plot as using a KDE, as specifying KDE. If we ask for a density plot, you can see that's exactly the same using matplotlib as well. And we could have done that the same way as we did with the first KDE plot by just df.plot and then specifying kind equals density and passing in density within quotes as a string. So you can see there. So basically 4 plots there, 4 ways to obtain the same plot, the same sort of density KDE plot, plotting the distribution of 4 variables. So there are a couple of things we can do as well. There are different parameters we can tweak for these plots. One of them is called the alpha, and that's how translucent the different lines are. So where we've got 4 lines plotted on top of each other here, and they're very similar in their distribution, it's sort of hard to see. So we can play around with some of the elements of it. We can see maybe that makes it a bit easier. We make them a little bit more transparent. We can see the different lines. Not necessarily the case there, but another thing we can do as well is adjust the line width. I'm not exactly sure what the default is. I think maybe this default would be 2. And if we set this line, LW is the argument, if we set line width equal to 4, then you see it makes the line width a bit thicker. So I don't necessarily think that's easier to visually interpret or see than the original one, and we might want to just plot each of those variables individually if we wanted to see what the distribution of them was. So in order to do that, we can use the same sort of syntax as we've done above, but where we pass the data frame, we just specify which variable in the data frame by putting it in brackets there. So df and then square brackets, passing mun as a string, and .plot.kde. So that's just all that's going to do is give us the plot for Monday, and we can see it's like slightly skewed. Same sort of thing for Tuesday. Let's have a look at that one. Looks slightly different shape, doesn't it? So you can see the difference in shape between the 2 there. And there's lots of other parameters we can use. Lots of things we can do to change the aesthetics or customize the plot. So one argument we could put in here is title. I've just put KDE density plot for Tuesday as the title. If we run that, you can see it's now just giving me a title on the top there. Okay, so that's matplotlib. Nice and easy to obtain these KDE plots. This type of way to visualize the distribution of a variable. Very useful thing to do. We can do the same thing in Seaborn as well, and as you know, I really like Seaborn. It's an easy to use software library for visualization and plotting. So let's do a similar sort of thing. I'll demonstrate how to do it in Seaborn and look at some of the different parameters and some of the things you can do in Seaborn, which are quite cool. So I'm going to import a data set this time. and I'm going to basically, it's this empty cars data set. I've got it saved as a CSV on my computer. It's a data set that's kind of seems to be readily available with different software. I think if you use R, it's part of it's one of the data sets that's included. If you can load it as part of the ggplot package and things like that. But you often see it used to demonstrate different sorts of things. So what I'm going to do is import empty cars as a CSV using the pd.read_csv method. I'm going to set it equal to, I'm going to assign it to this object called cars. So the data frame object is going to be called cars. And if I run that, you can see here we've got these 12 different variables and a row of data for a different vehicle. So if I do the .shape method, you can see we've got, it's not a big data frame, we've got 32 rows and 12 columns, so we've only got 32 data entries, but we're only interested in a little bit of plotting here, so good enough for our purposes. Okay, so what I am going to do is create KDE plots of a couple of these variables. I'll start with HP, which stands for horsepower. So we can create a KDE to look at the distribution of scores on horsepower for these different vehicles in this data set. And to do that, I'm going to use sns.kde_plot, and then in brackets I'm going to specify cars.hp. So all I've done here is basically said use the KDE plot from Seaborn, and the data I'm going to use is in parentheses, and that's the cars data frame object and the HP horsepower variable. So if we run that, we can see, so horsepower is a little bit positively skewed, I guess. It's not, it's starting to look like it's normally distributed, but you see 0, it seems to range, most of the scores seem to range between 0 and about 400 horsepower. Okay, so a couple of things we can do to make this look different, change the aesthetics of it, is we can color in the area under the curve essentially, and we can do that using this fill equals true. So the method we used to previously use on Seaborn was shade, so this would have been shade equals true, and if I put shade in there and run it, it will work. It will do what I want it to do, but it'll give me an error message saying that this method's been deprecated and that I should use fill instead. So if I run that, you can see what it does. Essentially, it creates this nice, it basically colors in the area, the area of distribution for the variable. Okay. Another thing we can do is adjust the bandwidth. So I played around with this. I'll run a couple of these so you can see. So when we've plotted histograms previously and they're discrete bars, we can specify the bin size for the bars, and the smaller the bin size, the more variability we'll get in the distribution of our histogram. Okay, and the wider the bin size, the more we can the easier it is to hide any differences between scores and things like that. With a KDE plot, which is obviously continuous, we don't have a bin size, but we can use this bandwidth argument. And it used to be, in Seaborn, it used to be BW, so we set BW equal to something. But like shade, that's been deprecated, and it's now BW_method. So if I set it to 20 for this particular plot, horsepower, what you can see is it's created almost like this normally distributed curve, but the horsepower, we know we've got very few values below 0. So by increasing the bandwidth, almost increasing the size of the bins, if you want to think of it like that, we've made our variable look like it's more normally distributed than it actually is. And if you change that, so let me run that again and say it's a 10, so I'm reducing it, but you see it's shifted a little bit towards the right, so it now only goes up to 2000, so it's moved this way a bit, and still centered around 0 a little bit, but and yeah, the range of it is kind of more 2000 to 2000. whereas this was on scale to negative to positive 4,000. But still looks like it's normally distributed, so can be a bit deceptive. So let me try a different value. What I'm going to do is set bandwidth equal to 0.5, and this looks like this was the default that Seaborn originally picked for this data frame. It looks pretty much like that first KDE plot we got if we set bandwidth equal to 0.5. And remember, the more granular make it, the smaller the values you add for the bandwidth, the more you're going to see all the differences, the variability in your data set. So you'll see lots of more zigzags and peaks and troughs. So if I set it equal to 0.2, so smaller bandwidth than this, what you can see is it's taking account of many more counts of the data, and it looks like a very different distribution there. Okay, so bandwidth, a way similar to adjusting the bin size on a histogram, essentially. And it's important, I think it's important to kind of play around with it, have a look at it. Seaborn will often pick a useful default, but it's important, I think, to make sure you're not deceiving yourself about how your data is distributed. So something else we can do, which can be used to confirm what we think about our data, is we can ask for a KDE plot, but ask for it to be set this argument cumulative equal true. And what that will do is produce one of these cumulative distribution functions for us. So it will like sum up to 1 the density on the y-axis. And so we could see, if we looked at this, if we looked at horsepower of 200, so we can see probably around about 80% of the data has a horsepower of 200 or less. Okay, so very, very few have higher than that. And I think I said in a previous video, when they've got this nice sigmoidal S shape, sort of gives us some sort of indication of how normal the data is distributed. In this case, it's reasonably well. It's not quite normal. We've got this kind of long tail here for the positive, where it's positively skewed. Okay, so just a couple of other things. That was, so far we've just looked at univariate stuff, just plotting one variable at a time in Seaborn. You can actually obtain KDE plots for 2 variables. So to do that, I'm just going to use sns.kde plot again. I'm going to specify the data I want. It's the car's data frame object, and I'm going to put horsepower on the x-axis and mpg miles per gallon on the y-axis, and I'm passing those in as strings. So if I run that, we get these nice concentric circles. These are almost like gradients they are. If you imagine looking at this from the top, this is kind of the peak of a hill. These are the slopes. And we can adjust, just like we adjusted bandwidth, we can adjust the number of levels to make this plot more detailed. So if I set n_levels equals to 20, what you'll see is we've used more and more of these rings. If you think about it, each one of these sort of these rings represents data that is of the same value. So this now looks like a really steep hill, essentially. Okay, so something else we can do, we can use the fill argument when we're plotting 2 variables next to each other. If I run that, you can see now, rather than getting these kind of OS map style gradient rings, we get we get differences in color, and in this case, the darker the color, the higher the density of scores. Think of it like looking it down at it from an aerial view from above. And we can, so this was fill equals true. We can add this extra argument here, C bar equals true. So leaving the fill bit, but if I run that, what you'll see it's done is it's put this this bar giving us the codes for the density of the different colors. So this is the lowest, obviously, 0.00003, 0.006 would be a top here. Okay, so as we've also seen previously, we can use this hue argument in seaborn to separate based on category. So I'm going to run this same plot again here, but we're going to specify hue equals AM, and I think this is related to transmission, automatic. A is automatic, M is manual, so a 0 or a 1 in this case. And if we run that, we can see zeros and ones. I can't remember which way around they are, but you can see it's plotted them separately. So you can see like the amount of horsepower at MPG rate varies quite a bit for the one that is coded 1, which could well be automatic. Let's try with a different. Let's look at it with a different categorical variable. So cylinder was in the data set. I think there were two, like 4-cylinder, 6-cylinder, 8-cylinder was present in the data set. If I run that, you can see there looking at the key. So let's get quite interesting. It's telling us something about this data, isn't it? That 4-cylinder engines, cars with 4-cylinder engines, have the lowest horsepower and in many cases the higher MPG, and those with 8 cylinders, this kind of purple one at the bottom, they have a range of quite low to high horsepower and pretty low MPG across the board. So those are just some of the things you can do. KDA plots, when you're plotting multiple variables, if you've got too many, it becomes a bit difficult to interpret, I think, but these seaborn gives you lots of options for, pick your preference of what you like, but really useful for plotting univariate distributions, plotting individual variables, see how they're distributed as well. Okay.